லின்சி அட்மின் அன்மியூட் பண்ண சொல்லுங்க, ஏன்னா அவங்க பேசுறது எதுவும் கேட்கல. அந்த அவங்கள மியூட்ல இருக்க அன்மியூட் ஆக்கி சொல்லுங்க.
ஆமா, வேற ஏதாச்சும் செய்யலாமா?
அப்போ இடியாப்ப தேங்காய் பால்.
Hello, Lindsay ma'am. Is it audible?
Yes, sir. You are audible.
Thank you, sir. Good morning to one and all present. It gives me immense pleasure to welcome you all for this faculty development program on fuzzy sets and systems, organized by the Department of Mathematics, Shift to Patrician College of Arts and Science, Chennai. I extend a warm welcome to our resource person, Dr. A. Felix, Assistant Professor of Mathematics, School of Advanced Sciences, Vellore Institute of Technology, Chennai. I wish all the participants a fruitful learning experience. Now, I call upon Dr. Lindsay to introduce a resource person to all of us. Hello, Lindsay ma'am. Hello. Sir, is it audible to you, sir? Felix, sir?
Sir, I'm audible. The listener is muted herself, sir.
Okay. So sorry for the inconvenience. I will introduce a chief guest to all of you. We have Dr. Felix among us, who have, as a resource person. He did his UG, PG, MPhil, and PhD from Loyola College, Chennai, and currently is working in Vellore Institute of Technology. He's also a research supervisor in the area of fuzzy sets, and he's guiding 4 research scholars now. We are happy to have you amongst us, sir. You can take over the session now.
Thank you, Professor Nagarajan. At the outset, I really thank the management of Patrician College, Department of Mathematics, for providing this wonderful opportunity to interact with you all through this webinar. My special word of thanks to Dr. A. Lindsay, Dr. J. Jensi, and Professor N. Nagaraj, the coordinator of Department of Mathematics. Shift 2. A set is the collection of well-defined object, which is given by the Russell. And if you talk, declarative sentence as a true value, either true or false, but not both. But Russell claimed that all language is vague and went for the saying that vagueness is a matter of degree. And now look at the statement. We said we know this logic is a true value. It has either true value, either true or false, but not both. And look at the statement. A liar says, "I'm a liar." Whether a person speaks truth or what's a lie? If you say this, he lies, then he himself accepts that he's a liar. Then we cannot call him as a liar. And if you say that he speaks truth, but this fellow is called as a liar. So this is a paradox. And one more paradox proposed by Russell, that in a certain city, all men either shaved by themselves or were shaved by the barber. And the barber only shaved the men who did not shave themselves. So now let us answer this question. Who shaves the barber? If you assume that barber shaves himself, but we have seen in the story that barber only shaved the men who did not shave themselves. It is a contradicting to the claim that barber shaves himself. Therefore, barber did not shave himself. So let us assume that barber did not shave himself. And look at this, the argument. All men in this town shaved by themselves. Therefore, barber can shave themselves. It's a contradicting the fact. So it's a paradox. We cannot assign two values for these two arguments. A liar says I'm a liar, and the barber paradox. So something in between true and false, in between 0 and 1, something we need to assign. So this cannot be dealt with a two-value logic. We need something called multi-valued or tri-value logic. From this argument, 1937 Bloch outlined the concept of fuzzy sets, but those days, he was opposed by many US great people. Therefore, he left the concept of fuzzy sets. And in the year 1965, Lotfi Alizadeh, who given a life to this fuzzy set and defined in the modern form. And he described the fuzzy set as a fuzzy set is a ordered pair in which every element of X will have the membership grade. The membership grade will take the value between 0 and 1, whereas the classical set, which takes the value either 0 or 1. And those days, to deal uncertainty, only the probability theory were used. Even you can ask the fuzzy set value will also take between 0 and 1. Probability will also take between 0 and 1. Why do we need fuzzy set? We can ask. But quenching the uncertainty by the probability is different rather than of instance to get a clear picture. And when do we need fuzzy set? Let me give an example. Suppose due to this COVID-19 circumstance, my intention is to have apple. So I send my brother to buy an apple with the red color in the market. I need an apple with the red color. So here, what is the possibility of getting apple in the market? Or what is the possibility of availability of the apple in the market? This is one of the uncertain. And second one, my intention is to have a red color. So what is the guarantee that my brother will get a red color apple? Because the color will vary. Maybe the apple may be purely red or partially red or no red. These are the possibilities are there. The first one, the availability of apple in the market can be dealt by our probability theory, whereas the what is the guarantee of getting the red color can be done by the fuzzy sets. And that's what the probability is, the frequency of likelihood that an element is in a class, and whereas the membership, which give the similarity of an element to a class. And of course, this example we quite often listen and learn from the expertise of fuzzy sets. So let us take a set of all tall people. In our view, if we take 5.10 is the height, what we assign in a classical set, the people who are height is more than 5.10, we will give the membership grade as 1. Whose height is, the people whose height is less than 5.10 will be given a 0. Here, our question is this: we are assigning membership grade 1 for 5.10 height, and also 6.2 also we are assigning the membership grade is 1. Look at this here. And what is the difference of giving a membership grade of 1 to 5.9, 10 and 6.2? And to show the difference, we have the fuzzy set. So look at this. At 5.10, it may be the height with the grade is 0.8, and then 6.1 with the membership grade is 0.92. And then when you keep on when you increase the X value, then the membership grade is also gradually increases. After a certain stage, consider a person height is more than 7. Definitely the height with the 7 feet will be minimum. Therefore, we can assign a membership grade. Even everybody can accept the people who are height is more than 7 or 7.2. We can give the membership grade is 1. This is how we assign a membership grade. The typical structure of giving the membership bell-shaped curve. So this is the typical structure of the membership function of a set. So here we know the support. Support is the membership, the set of all elements whose membership grade is positive. So look at this here. The membership grade is positive. That is called a support. Whereas the core is the set of all people who get the membership grade is 1. And after giving the membership grade of a particular set, we need to take a decision. So to take a decision, this alpha cut, which really plays a vital role. For instance, to get an admission at any good reputed institute, they will keep some cutoff. They will keep some 197, which means that the people who score more than 197, they are eligible to enter into the college in the particular institute. Similarly, after assigning the membership grade of a fuzzy set, we need to go for a decision. So if you keep the tallest people whose membership grade is 0.9, which means that the people who are whose height is 6.2 or more than that will be in the set by keeping the alpha cut 0.9 or 8. The height is the maximum membership grade. It would be the height. And next, let's see the convexity of the fuzzy set. So we know the convex take two element in a set, line joining the 2 points. That line joining completely lie in the set, then we can call it a convex set. Whereas it is defined in a fuzzy set. So this is our fuzzy set. Consider this is our fuzzy set. Okay. So if you say this is the convexity of the fuzzy set, this should hold this condition, mu of A, lambda x1 plus 1 minus lambda x2 greater than or equal to minimum of mu of x1, mu of x2. So look at this. Let me take these 2 points, x1, whose membership grade is 0.9, and x2 membership grade is something 1. So now let me take this parameter, lambda x1 plus 1 minus lambda x2, where lambda which lies between 0 and 1. And this value will be in between x1 plus x2. Look at this is the lambda x1 plus 1 minus lambda x2, and whose membership is 1. Now look at this. The membership grade of lambda x1 plus 1 minus lambda x2 greater than or equal to the minimum of this mu of x1 and x2. So therefore, we can call this the convex of fuzzy set, the convexity of fuzzy sets. Let us take this example. Take two different points, and the membership grade of x1 is, we know this, something 0.7, x2 is 1, and take this lambda x1 plus 1 minus x2, which lie in between them. This membership is 0.4. So 0.4 less than these two. Therefore, this doesn't hold good the convexity condition. Therefore, this is not a convex. Symmetry, you know this about any particular point. The mu of x plus c or mu of x c minus x are same. And this open left and open right close, which the F is to define a left and right membership function. So if you call your fuzzy set, call a fuzzy set, A is open left, then when x tends to minus infinite, the membership is 1. This is open left. When x tends to the plus infinite, the membership will be 0. This is open left. Similarly, we can define for open right. And the closed is both when x tends to minus infinity and plus infinity, the membership will be 10 to 0. Look at this. This is the closed membership function. Okay. There are various types of membership functions out there. So usually, you know, the triangular and trapezoidal, these are the membership functions plays a prominent role in all the decision-making analysis. To get a clear picture about this membership function, let me take an example. Of course, so let me take for explaining purpose, let me take this particular example. What is the right age to get married for a man? So usually, you know, our ancestors would say this 27 is the appropriate age to get married. But our question is that, what about 28, 26? Are they not very closer to 27? So here, the uncertainty arises at this particular point. Uncertainty arises this particular point. Therefore, we can take at least to get married, a man must have 22, and if his age more than 32, in our view, you know, he may not be fit into to get married. So this is one of the observation. So therefore, we can, if the person age is less than 22, his membership is 0. Greater than 32, membership is 0. In between them, we can define. It's one of my observation. It varies people to couple. But so age, for 27, we cannot keep exactly. Instead, we can go for some interval. So 25, 29, if we keep an interval, that would be fine. So we can assign a membership grade for from 25 to 29, or very good to get a marry with a membership grade is 1. Now the same question arises. What about 24, 28, sorry, 30? Are they closer to 29? Of course, 24 is also closer to 25. Therefore, the uncertainty arises at the interval. So when the uncertainty arises interval, we can have the membership grade in the form of trapezoidal form. So these are the two predominant. It is the linear membership function, and this can be defined like this. So either we can, so look at this, it is in the form of triangular. Okay, uncertainty at B. Therefore, you have taken the value which are closer to B. A, B, C, we have taken. When X less than A, the membership is 0. When X lies between A and B, we can give the membership grade X minus A divided by B minus A. Similarly for right strip as well. We can also define this membership function through max-min operation. And similarly for trapezoidal fuzzy number, we can define. So you can see this. Okay. And these two fuzzy numbers are linear, and people are also working on extending this fuzzy numbers for fifth pentagonal, hexagonal, heptagonal, octagonal, non-ordinal, decagonal. People are doing with the different membership function with the linear as well. So for non-linearity cases, we have Gaussian membership function. This is bell-shaped curve, the normal curve. This is defined as e power minus 1 by 2 x minus c by sigma. Here c is the center. The normal distribution is about the center and the standard deviation, about the mean and the standard deviation that we have seen in the normal distribution at the statistics. The same way here, the Gaussian membership function with respect to our origin, the center and the sigma standard deviation. And look at this, if I increase this power to the higher number, then what will happen? This width will be minimized. So if I increase this 2 to 3, then what will happen? The width will be decreased. And this is the typical structure of the bell-shaped curve. Look at this from here only. When the non-linearity tends to the linear form, what will happen? You will get trapezoidal. So when this B is equal to C, then what will happen? Becomes a triangular. Okay. So the typical structure of a membership function is the bell-shaped curve. Here C is the center, A is the width of the x coordinates of the distribution, and B is the slope of the curve. And the fifth one is a sigmoidal membership function. This is 1 by 1 plus exponential of minus A x minus C. And this membership function has been applied very well in the neural network to activate the function. So this is one of the important membership function rather than your triangular trapezoidal. At non-linear case, this sigmoidal function plays a vital role in activating the concepts in a neural network. So other types of membership function, just now we have seen that left close membership function, right close membership function. Using the concept, the researchers have also defined LR type of fuzzy membership function, S plus S negative membership function. So pentagonal, they have also extended the membership function into the higher order. And intuitionistic fuzzy membership function is also there. It's an extension of the fuzzy sets. Okay. So we the human has a capacity to measure a thing. Even if you ask a child, do you like a mother? The child would immediately reply that I love my mother very much. Only the human can measure our feeling and emotion with the linguistic terms. So each, of course, it varies to person. Okay. So each linguistic term, such as cool, medium, or hot, is taken. Okay. So in a particular temperature, someone feel this degree, this temperature may feel a cool, medium, or not. Here we have assigned this value for the linguistic terms. Cool is represented as 0, 0, 10, 25. Is represented by the trapezoidal membership function. Similarly for medium is defined from 23, 27, and some 32. We can define the linguistic term with regard to the membership function. Okay. Now let's move on to the operations on fuzzy sets. Okay. So A contain B. If we say that the inclusion of fuzzy set A containing B, if the set of all membership of A should strictly less than the set of all membership of our B. So now look at this. This is the fuzzy set A. This is the fuzzy set B. Here A is contained in B, the first one. So when you call it, two sets are equal if the membership of both A and B are same. And complement of a fuzzy set. The complement of fuzzy set is defined as 1 minus A of X. Bar of X is equal to 1 minus A of X. Okay. So usually to represent the fuzzy set, some author will denote A tilde and B tilde for explaining, for making a presentation neat. I made it as A, B, C, D. I have not used the tilde. And other operation, this and or operation plays a predominant role whatever you take. Okay, so even for English to connect the statements, these two or and operations are very well used. So here the union operation can be used as the fuzzy set as the maximum of mu of Ax and mu of B of X will be the A union B. The intersection B is defined as minimum between them. So now look at this. So this is A and B. B are two sets. The A union B will be, this is our A union B. This is our A union B. Whereas the intersection part, the minimum between them. So this is the minimum. Okay, this portion, the intersecting part. So we can also explain this with a numerical example. Let us take A and B, the two sets, fuzzy sets. The A dash will be 1 minus of membership of A. So 1 minus 0.1 is 0.9. Similarly, we can define A bar. And A union B will take the maximum between them. A intersection B, take the minimum between them. 0.4, 0.3, 0.3. Okay, this is how we can define the union and intersection fuzzy sets. Okay. Some another standard operation on fuzzy sets, the algebraic product of two sets. So mu of A into B is equal to mu of Xi, mu of B of Xi. There is a sum of two fuzzy sets. Now look at this. If I want to add these two fuzzy sets, if I add the first, we are taking A, and second time when I add, this portion is being added twice. So this is what we have learned as the inclusion-exclusion principle. That's what additive theorem of two probability events. P of A union B is equal to P of A minus P of B minus P of A intersection P. So therefore, this is counted twice. Therefore, this portion has to be eliminated once. So because why we are saying this? Now look at this. If we add the ordinary operation 0.6, 0.7, we'll get 1.3. We know this, the fuzzy value will not go more than 1. Therefore, yeah, that's the reason the algebraic sum of two fuzzy set is defined like this. So let us take these two examples, A and B. This is the algebraic product of two fuzzy sets. The algebraic sum of fuzzy sets will be x1. Mu of x1 is equal to mu of x1. Sorry, mu of A plus B is equal to x1 is equal to mu of x1 plus mu of x1 minus mu of A into B x1, 0.19. Similarly, we can define algebraic sum of two fuzzy sets. Okay. So in classical set, we know the fuzzy set will not hold good only two properties of a Cripps set. So that one is law of excluded middle. So at this A bar is equal to X and A union A bar is equal A bar not equal to X. Let's see the example. A of X is equal to, this is the fuzzy set, and A bar is equal to, which means that the x1, x2, x3, x4, how far belonging to my set A. A bar means how far the element does not belong to the set. That's what A bar meaning is. So if I take A union A bar, this is not equal to my inverse discourse. So inverse discourse is there X, in which the uncertainty only at my A, only at my A. So therefore here you talk about the element of A, how far it belongs to a set, how far does not belong to a set. Okay. So therefore, that's the reason if you look at the introduction to fuzzy subsets of Kaufman, he called fuzzy set as a fuzzy subset, because in the inverse discourse, the uncertainty only at a particular set. Therefore, he called fuzzy subset. Therefore, this is A union A bar not equal to X. And another one, law of contradiction. So we know this A intersection A bar is empty, whereas at fuzzy, A intersection A bar not empty, non-empty. Similarly, so A union A intersection A bar supposed to be empty at the crisp set, whereas here what we obtain, if you take the intersection between these two, what is the intersection means? The minimum between these two, 0.3, 0.4, 0.5. So therefore, this is not whole good of our law of contradiction. So these are the two law doesn't hold good at fuzzy set. Okay. Now let's go for some interesting concept, the fuzzy entropy. You know, people are also working on fuzzy entropy in pattern recognition at image processing. So this fuzzy entropy helps us to measure the fuzziness of the fuzzy set. For example, let me tell you, suppose we have a kind of photo which is damaged one or blood one. So even if you take your what is that, your child age photo, this photo may not look clear because due to the year, you know, the photo might have been damaged. So here we want to find out how far photo is blurred, how far the photo is in fuzzy. So let us take, this is A of X is our photo. So let me take X1, X2, X3, X4 are the parts of our photo image. Okay. So we want to find out how far the image is under fuzziness. So by using this minus 1 by n, sum of mu of xy log of mu of xy plus 1 minus mu of xi into log of 1 minus mu of xi. Using this, we can obtain the value 0.249, which means that there are almost 25% the photo is damaged, or there is a 25% fuzziness occurs at the photo. This is how we can come to conclude. And measure of inaccuracy of a fuzzy set. So let us here A of X and B of X, two fuzzy sets. Let us take a two different or same photo. Let us take a two same photo. One is a damaged one is slightly damaged. So here we need to find out how far one photo is fuzziness with regard to the another photo. So let us take A of X and B of X. These are the same image, whereas one image is completely damaged. There are a lot of uncertainties there. Okay. We can measure the inaccuracy of a fuzzy set B with respect to A. So the B is damaged 47% when you compare to your other image A. This is measure of inaccuracy set. Okay. Now let's move on to the distance. You know, this Hamming distance, relative Hamming distance, which really helpful for us in clustering concepts. You know, clustering, we know this, to group a data. When you have a large amount of data, to analyze it's not an easy task. Therefore, what people will do, they will go for the grouping concepts. The data are similar, then they will put it into one cluster. So how we can find the similarity of an element of the data? How we can define? Through the distance. Usually, you know, this is simple question. When I was a child, our teacher would ask, so when do you say 2 points are equal? When the distance between 2 points are 0, then they are equal. So if we keep the radius is something acceptable space, then we can make a neighborhood. in these aspects, we can form a clustering. So Hamming distance, a relative Hamming distance, Euclidean distance, relative Euclidean distance, a Minkowski distance would really helpful for us in clustering the concepts. Okay. Now let's move on to the Cartesian product of two fuzzy sets. So A of x is defined in x and B of y defined in y. The Cartesian product of A of x and B of y is defined as mu of A intersection B is equal of x comma y. This is equal to minimum of mu of A of x comma mu of B of, sorry, this is y actually. This is y. Okay, let us consider these two fuzzy sets. Okay, so the Cartesian product of this x1 comma y1 will be taking the minimum of the membership of mu of A of x1, mu of y, mu of B of y1. Okay, 0.8. The minimum is 0.1. Similarly, we can find for x1 to y2, x1 to y3. We can obtain. So this concept has initiated us to think about the fuzzy. I know, even if you look at, if you draw the figure, you will get the bidirected graph. Okay. And now let's move on to the fuzzy inference systems. Okay. So far we have learned the concept of fuzzy set, the membership function, operation of fuzzy sets, and then what is it? Entropy concepts and the distance measurements. So with this information, let's learn the fuzzy inference system. Okay. The fuzzy expert system is based on expert knowledge. Okay. So there are many fuzzy expert systems of the fuzzy cognitive maps. So initially the cognitive map was proposed by Axelrod, and then the fuzzy logic and neural networks were combined to bring it out to many models by Bart Casco. So Bart Casco who said that the fuzzy and neural network are two sides of the same coin. So which, when you make a model with regard to the fuzzy logic and neural network, which mimic how human thinks, that's what Bart Casco said. And later he proposed bidirectional associative memories, fuzzy associative memories. And then Mamdani Sujano has also proposed fuzzy inference system. But in our talk, this webinar, we will focus on this Mamdani Sujano method. This soft computing terminology was coined by Professor Lotfi-Zadeh in the year 1994. So in which comprises the fuzzy logic, neural network, and all the revolutionary algorithm. Antonesov, 1994, proposed the intuitionistic fuzzy sets. Okay. So fuzzy inference system acts on the basis of the knowledge based. Okay. So the knowledge base consists of rule base and the database. So which works on the basis of if-then rule. Okay. So it has a different name: fuzzy rule based system, fuzzy model, fuzzy associative memory, fuzzy logic controller, and fuzzy system. These are the names are available. We can classify the fuzzy inference system into two aspects. One is linguistic fuzzy modeling. Another one is precise fuzzy modeling. In linguistic fuzzy modeling, we have the high interpretability and which has a low accuracy. And at precise fuzzy modeling, we have low interpretability and high accuracy. For linguistic fuzzy modeling, Mamdani approach would be the appropriate one, whereas precise fuzzy modeling, Sujano approach. Here, the input factor are classified into the linguistic terms. The input I1 is L and I2 is M, then output is high. So the input and output are, the if-then rules are framed for both input and output with the linguistic terms. Whereas at the Sujana, the output will be the function of I1 and I2. This is the only difference between Mamdani and Sujana. Okay, the output will be in the form of of linguistic terms or fuzzy set, whereas the output will be in the form of the function, will get the crisp values. But here, the output which be the fuzzy one will be defuzzified. That we'll see in one by one. Okay, so this application of fuzzy inference system, a lot of applications are there: data classification, decision analysis, expert system, time series prediction, robotics, and pattern recognition, and so on. But mostly Japanese people have applied this fuzzy concepts very well. Even they've registered more than, I think, around 6,000 patents. Compared to US, Japanese have used this fuzzy concepts very well. They've also used the fuzzy concept at Sendai Subway 1000N series to start and stop the train smoothly. So when they incorporate the fuzzy concepts in the station, it acts better than the human efficiency. Okay. So it acts better than the human. They're saying this 10% more energy efficient than human controlled acceleration, and that was developed by Hitachi. Okay, the fuzzy inference system has three processes. One is fuzzification, inference process, and defuzzification. So at fuzzy inference system, let me go with this simple story. So whenever we are not feeling well, we used to meet the doctor, isn't it? So in our experience, who would be the best doctor? So, usually the people will say, whenever doctor asks the question, usually, doctor will ask the questions. They will keep on asking the question. The patient intention is to say yes, everything. So what patient thinks that if we say yes for all the questions of the doctor, then only doctor will give the good medicine, then all our disease will be cured. For instance, suppose doctor would ask, do you feel headache? At present, we may not feel headache. We may had, our intention is to say yes. Then what, and then you would ask, keep on asking the question. Then, we will say yes, yes. Then doctor will give the medicine. But another type of doctor is there. The doctor would make the patient to talk. So what is your problem? Then what will happen? The patient who can spell out all the problem that they are facing. They can spell out, I feel very headache. I don't feel hungry. What is it? So many, whatever the problem that we are facing, we will list out. From that, from our whatever we spelled out, from that, doctor will identify, okay, he or she may have this particular disease. So doctor will give some dose. So, after giving a dose, doctor would say that continue this tablet for 2 days and then come and meet me again. So what we'll do, if the disease is cured, we won't go and meet the doctor. So if it is not cured, we'll meet the doctor. Doctor will change the dose. Still, the disease has not been cured. The doctor will go for the medical checkup. Doctor asks us to take blood tests and all the tests. From the tests, he will come to conclusion that you may have this particular disease. Okay, so this is how doctor can forecast, how he can, with this knowledge. So he has come across many many cases. He can easily diagnose by looking at the the medical report. So this is the particular disease. So here, the fuzzy inference system has also just mimic how the doctor thinks. Okay, so the first one is the fuzzification process. Here, to identify any particular disease for typhoid or anything, we have a certain parameter. So these are the parameters taken as an input, and all the input are classified into the linguistic term. We will fuzzify the things, and then we will frame a rule. If fever is this much and continuous urination this much, and so on, then she may have this particular disease. This is how doctor will come to conclusion. The fuzzy inference system works on the basis of if-then rules. Okay, and at final stage, the defuzzification, whatever output we obtain, will be in the form of fuzzified one that has to be defuzzified with so many techniques that we have. So that also we'll see in that. Okay, this is the fuzzy inference system. Whatever the data, whatever the input we feed into that, the fever can be classified low fever, high fever, very high fever with regard to the temperature. And then, yeah, so we will fuzzify the thing like low, medium, high. And then here we will frame a rule. If the fever is high, then and what is it? Some other blood, red blood cell is low level. We will classify low level. Then what will happen? We will frame a rule. Then we'll get the output. This output will be defuzzified. This is the fuzzy inference system. Okay. So this is how we will frame a rule. If the input U1 is F1 and U2 is F2 and U3 is F3, then the output V is G1. For instance, here also we can, if education is low and expenditure is low, then salary is very low. Similarly, we can frame a rule. Okay. After framing a rule, we'll incorporate in the system. Okay. This is the fuzzification inference engine. Okay. Suppose education is low with some membership grade 0.6, and then the education is this is medium with the membership grade is 0.5, and another one, what is it? Experience is low with this much of membership, and experience medium with this membership. So this is the output. When you combine these two, this is the output we obtain. This is we need to defuzzify. Okay, this is the output for this particular rule. We need to defuzzify the things. To defuzzify, we have in the history, most of the researchers have used these are the four defuzzification method. So defuzzification is the conversion from fuzzy to crisp. So we have the center of sums method. So the thing is, the final output should be converted into the crisp scale. So this is the output we obtain for this particular. Okay, so this is in the form of fuzzy. We need to convert it into the crisp one. So these are the available defuzzification. Even still, people are also doing with a different defuzzification. Okay, the first one is the center of sums of method. Consider this is the output that we obtain. Okay, A1 and A2. Okay, here what we are going to do, here we are going to find out the median, the center. Okay, we are going to find AI is nothing but the area of the first one, A1, into the midpoint of the A1, and divided by the sum of the area. Okay, let us take the first A1. Okay, so A1, we know the area of trapezium is 1/2, the height into the breadth and the perpendicular distance between them. This is B. Okay, so look at this. First, let us take this A1. Okay, the base is, so 1/2 height here is 0.5. Okay, and A is, what is that? The 8 minus 1, the length, the base height is 8 minus 1 plus the perpendicular distance between them, this one, 7 minus 3. So this is 2.75. Okay, similarly A2 we obtain, and then we need to find the center point, the centrality of the fuzzy set A1 will be, so look at this, this is the center portion, 7 plus is the center portion of my A1. So 7 plus 3 by 2, we can have 5. Similarly for second fuzzy set A. So therefore the defuzzified x bar is equal to A1 x1 bar plus A2 x2 bar divided by the area A1 plus A2. Therefore we obtain 5.35. This is how we can obtain the final output from the fuzzified one. And another one, center of gravity or center of area method. Here the region is divided into so many sub-regions. Okay, so look at this, the same, let us take the same A1 and A2. Here we are divided into so many sub-regions. Okay, here AIs are the sub-region and AXI bar is the mean of the sub. So this is the triangular. We know the formula of determine the area of the triangular. This is rectangular. and this is also rectangular. Similarly, we can do this. We can. Okay. So first, let me do for one thing. So the sub area of one, a triangle is 1/2 breadth and the height. So this will be, so 2, the height is 0.5. The centroid of the area will be 1 plus 3 plus 3 divided by 3, 2.33. Similarly, for all the areas are calculated. So the defuzzified is 5.008 for this. So initially, what for center of sum method, we obtained 5.35, whereas the same set we have taken here, 5.008. And the third one, weighted average method. Okay. This method is valid only when the membership function is in the form of symmetric. Okay. So you can see this is symmetric about the origin, symmetric about the midpoint. Okay. And the thing is, the computational will be, the complexity of the time will be less here. Okay. And here each membership function is weighted with the maximum membership grade. Okay. Here each membership function is weighted by the maximum membership value. So let us take the same example. Let me take the student who scored marks. Okay. The pass percentage of a particular class is 0.6, fair is 0.4. Okay, 0.4 fair, and then good is 0.2, and then very good is also 0.2. Extraordinary excellent is 0. Okay, this is what we have taken. Okay, but here we have seen that the maximum of the membership of an element will be taken. Okay, for every membership function, the maximum grade will be taken. The 60 scores 0.6 plus, and 70 score 0.4 plus, this 80 score something 0.2, and 90 score 0.2, 10, 100 score 0, and divided by the membership. So we can get what the defuzzified value is 70. The last one, the maxima method. The first one, first of maxima method, and last of maxima, and mean of maxima method. The first of maxima method here, in the domain, the smallest value with the maximum membership function. Okay, this is our domain. In the domain, the smallest value with the maximum membership grade. So here 468 will have the membership grade is 0.2. Among them, smallest element with the maximum membership grade is 0.8. The second one, last of maxima method. In the domain, the largest element with the maximum membership function. So here 8 is the largest element with the membership function is 0.8. And mean of maximum method is when more than one element with the maximum membership function, then take the average of it. Now look at this. So 468 will have the maximum membership function 0.8. Take the average of 468 by 3, 6. Okay, so we have seen these 4 defuzzification method. If you ask me which one is the best, but we cannot say that which one is best. But computationally, for the time complexity, we can go for the maxima method. Okay, now the researchers are also working on a different defuzzification method, and if you give the different defuzzification method, you should also compare with the existing techniques and how far your acts better than them. Then only we can say. We cannot say this one is the best. So we can say comparing that, it acts better. Okay. So now the Sujana fuzzy model, as I mentioned that the difference between the Sujana, Takaki Sujana, and the Mamdani approach only with the output. Here, the output will also be in the form of fuzzified one in the Mamdani, whereas here, this is in the form of function of your input variable, X and Y. This is the difference. But here at the Sujana, we obtain the output will be in the form of crisp one. Here, no need to defuzzification. So no need the defuzzification method. Okay. So for example, let us take these are the situation if X is small, then this is 0.1 X plus 0, 6.4. If X is medium, then y is 0.5 x plus 4, x is a large, then this is the output. Here we take this small, medium, large as non-fuzzy sets. So look at this non-fuzzy in the sense the boundary will be sharp. Okay. So the overall output will be in this form. Overall output, whatever we have made it, whatever we made it here. Okay. And then if you take the smooth membership function, then the output will be in this form. The only thing is the output will be in the form of function of the input variable. And Tsukamoto fuzzy model, here the final overall output will be obtained by taking the aggregate of the each input or each output. This is the extension version of our Takaki Sujano method. So this is the only difference. There is a third one. The overall output will be aggregated of each rules of the output. Okay. The Tsukamoto fuzzy model. If x is small, then y is C1. If x is medium, then y is C2. If x is a large, then y is C3. So now look at this. This is what small, medium, and large is taken. This is the corresponding, the consequent, the output, the corresponding output. If condition, then this is the if consequence. Okay. The corresponding each rule's output. If this is so, then what will happen? The corresponding output. Now these all the rules are taking the aggregated. This is the final output. This is Tsukamoto fuzzy model. Now let me demonstrate the Mamdani approach fuzzy inference system in diagnosing type 2 diabetes mellitus. Okay, the algorithm goes like this. At step 1, we need to identify the n input factor, m output. Okay. And then at step 2, divide the input factor and the output factor into linguistic terms. We divide all the input factor and the input and output into the linguistic terms, and we provide the suitable membership function for all the linguistic terms of the input and output. And at step 4, we will frame a rules, if-then rules. If this is so, then what will happen? We'll frame rules. Before we are making a rules, first we'll make a string. This is the first input, and here we are using the AND operation. This is the second input, and this will give the firing strength. Okay, it will give the out. If-then rules. The final output will be defuzzified. Okay, the final output will be defuzzified. That will be the required diagnosis of the disease. Okay. The type 2 diabetes mellitus is one of the alarming diseases in both developed and developing countries. And the undiagnosed diabetes leads to many complications, even our eyes, heart, nerve system, kidney. So how we can diagnose the thing? The same thing, at the rural area, we cannot have the medical expert easily. Instead, what we can do, we can make this kind of system. We can the system which mimic what the expert doctor thinks. So that's what here we have made it here. So here at step 1, we take a 5 input variable. To understand this particular inference system, we have taken this particular problem. So to diagnose the diabetes, these are the 5 input factor we can take: age, high density lipoprotein, low density lipoprotein, and body weight, and physical activity. This is a BMI index, physical activity, and the output will be health condition. So this is what we have chosen. And at step 2, we classify all the input variable into linguistic terms. Look at this. The age is classified into age, adolescent less than 20, youngest 15 to 35, middle, middle 30 to 50, old is 45 to 65, very old greater than 65. And we provide the suitable membership function for all the linguistic terms. For instance, adolescent, when x less than or equal to 15, the membership grade is 1. When x lies between 15 to 20 is defined as 20 minus x divided by 5. When x greater than or equal to 20, then the membership will be 0 at the adolescent. Similarly, we can define for Now look at this. Let me take the age is 32. The 32 will also lie at young and middle. There is overlapping. Now let us see the 32, how far he belongs to the set young and middle set. When you substitute here 32, so 38, yeah, it lies here. Then we will obtain, what is it, 35 minus 32, 3 by 5. So this is 0.6. A person whose age is 32, which belong to the young set, where the membership grade is 0.6. Whereas at the middle age, 32 minus 20, this will be 2 by 5. 2 by 5 is, this is 0.4. So E belongs in the middle age with the membership of grade is 0.4. Yeah, okay, this is a classification of age. Similarly, the high density lipoprotein, low density lipoprotein are classified into linguistic term and suitable membership is given. So here, how we framed with the available information with the help of the doctor only, we can frame this kind of classification and provide the suitable membership function. So only with the expert of the field can give us to classify and to make a membership function. Okay, and then body weight. So BMI is classified underweight, normal weight, overweight, obesity, and the physical activity, how many hours, how many minutes you are really doing exercise per day. So based on your physical activity, we can classify low effective, slightly effective, very effective, enormously effective. We can classify the thing. The output will also be classified very low. The health condition is classified into the 7 linguistic variable: very low, low, medium, medium, severe, severe, very severe, like this. Okay, and then with the help of 2 medical expertise, so 1200 rules are created. The rules will be like this: if age is adolescent, high density lipoprotein is low, and low density lipoprotein is optimal, body weight underweight, physical activity low effective, then the health condition is very low. Similarly, all the rules created, and then everything is incorporated at the MATLAB. So this is a fuzzy rule base. So you can see the scale. You can move here and there. Like, yeah. So on particular case, age is 40, high density lipoprotein 45, 135, physical activity, body mass index is 30.5, and physical activity 1 hour. Then his health condition is 0.7. So here you can ask, what is the optimization here? So here you can optimize the thing that you can reduce the width of the membership function. That is one of the way you can optimize the thing. And second one, we can also minimize the rule. So no need of this much of rule. If you have 1200 rule, it would be hectic for us to analyze. So you can also minimize the rule. These are the 2 things where we can concentrate to minimize to optimize the system. Okay. So let us take this particular case, the input variable patient P1 is age 40 and the high density lipoprotein is 45, low density lipoprotein 135, body weight 30.5, the physical activities is 60. So, and then this will be classified into, provide the suitable membership function for the situation. And then we'll frame a rule for whatever the rule is available from it, we can determine. Here age is middle with the membership grade is 1, medium high density lipoprotein was 1, and low density lipoprotein is 1. Then, and occurs at rule 608 says that the health condition is severe. So hence the patient is affected, type 2 diabetes mellitus, in a severe level. So this really helped the patient to diagnose the disease, and also we can detect early so that the proper medical treatment can be given to them. So nowadays, we are facing this COVID-19. We can also frame this kind of model for COVID-19. Now, the current trends of the fuzzy research would be the fuzzy optimization. fuzzy clustering, artificial fuzzy neural network. As I said, neural network and fuzzy logic are two sides of the same coin. When you combine them, it acts better. It mimics how human thinks. That's what podcast was suggested in proposed a lot of model on fuzzy neural network. Application of fuzzy logic in computer networking, data mining, knowledge management, and also decision analysis. Most of the people are working the fuzzy decision maps, decision demattle techniques, Tops's, Vega, Electric, and so many models are there. So when you find a different membership function, you can incorporate in the available model, and how far your membership function acts better than the other existing techniques. Such comparative study we can also make. So these are the references I've taken for my presentation. Thank you very much. Nagarjun sir. Hello. Admin Nagarjun sir, you can unmute and you may talk. Hello. Yeah, any questions from the audience? You may let us discuss. If I'm able to answer, I'll definitely. Participant, you can unmute and you may ask the question. Hello. Am I audible, sir? Hello. Anyone can unmute. Admin, can you unmute yourself? Can you say?
Hello, Felix sir.
Sir,
Is
sir
it
yes,
audible?
sir. Yes, yes,
Very
sir.
sorry for the inconvenience, sir.
Okay. Dear participant, I'm really, we are very sorry for it. There is a,
We're very sorry, participants, for the inconvenience caused. We have certain questions raised in YouTube channel, which I'll first ask to Felix sir.
yes, sir.
Sir, we have received certain questions, sir.
Yeah, yeah. Yes, sir.
Yes, sir. I'm just. This is Professor Uday Kashid from Vidyalankar Institute of Technology, Mumbai. He's asked
Yes,
two questions, sir.
yes,
Is
yes,
fuzzy
sir.
set theory capable to handle incomplete information data?
Hmm.
This is the first question he's asked.
Hmm.
And the second one is how to avoid or minimize loss of information due to defuzzification process.
Yeah, good question, sir. The defuzzification, lot of defuzzification techniques are there. We need to look at the situation and then only we can go for it. The first one, when you have, when you do not have the, how far you have information. Based on that, we can fuzzify the things. And one more question asked by one of the participant, and how we can give the weight for the average method. So now look at this here. We have taken the maximum membership function, maximum value of the membership function is taken. So 60 obtain, the membership grade is 60, and 70 is obtained, membership grade is 0.4. 80 is obtained in this membership function, the maximum is obtained with the 0.3. This is the answer for the participant who asked the question. And that's it, sir.
Does anyone here have a question in the Zoom live app? You can raise your hand so that I can unmute you. You can ask the resource person the question. Ramesh, Mr. Ramesh?
Hello.
Yes, sir, you can ask your question now.
Yeah, sorry, sir. By mistake, it will, sir. Sorry.
Okay, thank you. Does anyone have a question to ask? You can raise your hand. There is an option available so that I can unmute you. Bhaskar Murthy, Mr. Bhaskar Murthy?
Yes, sir.
Sir, you can ask your question, sir.
Sir, how these fuzzy sets and neural networks are capable of doing in data science?
Sir, at data science, we are also working. We are trying to work on it.
Okay, sir.
But the thing is, I worked in the neural network and fuzzy inference system to frame a model. Yeah, the creating a if-then rules where the neural network will be applied, where the input parameter are taken as the neurons. Okay.
Yes, sir.
And then
Yes,
the weighted between two neurons will be calculated by the firing strength, sir.
Okay, sir. Thank you.
So we have some more questions from YouTube.
Okay, sir.
They're asking the gradation which will differ from person to person, then how will it be well defined?
Yes, sir. Actually, it's a good question. Even in our India, the people whose height is 6, I mean, 5.5 may not be tall at India. If you look at other country, Nepal, China, 5.5 would be the tall. The uncertainty arises at the endpoint as well. But in this situation at India, the people height is 5.2 or 5.4. They are not tall, they are short. But when you look at the China in the other countries, this height will be the tall. Different situation where we have a type 2 fuzzy logic that audience participant, please look at the type 2 fuzzy sets. The uncertainty arises at the endpoint. It varies, sir, place to place. But now we look at particular our situation. We can look in our situation. But if I take into the different phenomena or different environment, it will change, sir. It will vary.
Okay, thank you, sir. And one last question, sir. What is the difference between fuzzy sets and rough sets?
Sir, actually, here the lower membership and the upper membership will be taken at the rough set. I'm not working on it. I've listened some great people talk some 2 years back. I'm not very good at rough set theory, but that's the only difference. Here the membership will be taken from the lower and upper membership function. Lower and upper. In between the value will be taken, sir. So let me also work on it, sir. I'm not very good at it. This is the difference, low and upper. The membership grade will take.
Thanks a lot, sir. As we have come to the end of the session, I would like to remind the participants that e-certificates will be dispatched only after feedback form is completed, which is already sent along with the invite mailed yesterday. I repeat, participants should compulsorily complete the feedback which has been sent to them by mail yesterday to get the e-certificates. Now, as we have come to the end of this session, which was a very knowledgeable experience, I wish to thank everyone who made this possible. I extend my sincere thanks to our college management for their unconditional support. I wish to thank our Director and Secretary, Reverend Brother Johnson Rex Dhanapal, our Academic Director, Dr. Fatima Wasim, our Principal, Dr. Usha George, and Vice Principal, Dr. Geeta Rufus. I thank a resource person, Dr. A. Felix, for this knowledgeable session and also clearing the doubts of the participants. I would like to thank our friends who have constantly encouraged us throughout. I thank you all for your active participation. Thank you, sir.
For this wonderful opportunity.
We are ending the session now. Thank you.